Well, hello there and welcome back. We're going to play with Linux again today, but I wanted to show you kind of the power of starting to understand command line interfaces. And usually when I'm going to get into my server with AWS, it's restarted things and all sorts of stuff. Well, I might, the IP has changed, the DNS changed. I won't know what it is unless I log into AWS and find it. So what I'd like to use is the command line interface, and I can use that on my local computer, but the Learner Lab has the command line interface right here, and I've ran this. I've got this command ready. In fact, let's make this bigger. And if I remember, I'll link this command down below, especially since it's wrapping now. And what this is going to do is it's going to go there. That's just a little too big. It's going to go out to AWS, get my DNS name, my IP address, my instance ID. This I need if I want to automatically delete it, terminate it. My key and the name. So I'm going to play with this server today. So this is the DNS that I need to connect to. Cool. So I'll just come here to a command line, SSH ec2-user at and that DNS name. And its IP's changed. That's fine. Okay, so I'm in. Now, so today, what I want to do is I want to play with links and mounts and help you understand some of the interesting details of Linux file systems, inodes. So let's go ahead and clear this so that we have it up top. In fact, let's also do, because if I do history, okay, there's not much here, but let's do history -C to clear it. So we'll start really fresh. Now, if I type in pwd, we'll see that I'm at my user directory. I don't think I have anything in here. Cool. So I'm going to mkdir temp, and let's change directory into temp so I can play with stuff there. That way I can delete the entire temp directory when I'm done if I want to clean it up. So let's look, there's nothing here. So let's mkdir here. And if I do an ls, I can see it's there. If I do an ls-l, it gives me a little more information. I want to do an ls-li. And this gives me, if we look right here, there's this number. So let's do man ls, and let's look at what that I is for. In fact, -i, next one, right here, -i. Print the index number of each file, also known as the inode. Print the index number. Okay, so this is a pretty cool thing with the file system where you can track things by inode. In fact, you can also, one of the hooks that we've used in Linux in the past is an inotify. So we can see when a file is created or started to be created or finished saving in a certain folder and trigger an event. Okay, so it's a really cool thing to play with. But so inodes give you a little extra stuff that you can do. So let's create a file, touch, and we'll just be simple one. Now if I do ls-li, I can see we have this one is a file, and here is a directory. Okay, so now let's do an ln, which is a link, and we're going to do a soft link or symbolic link. Not sure, I've heard it both either way. And we're going to link to here, and let's call it there. Okay, so now if I do an ls-li, I can see that here and there both have different inodes, but there is pointing to here. Kind of weird. So if I do do another one. ln dash s. So we have 1 here, right? 1 space 2. Enter. And now if we do ls dash li, we'll see here's the 1, here's the 2 pointing to 1, and here's the here, and there's the there pointing to here. Cool. What if I do an ln 1 space 3 without the soft? Okay, ls dash li. And here we have 1 and 3 have the exact same inodes. It's not pointing to another, it is the other. Okay? They're the exact same thing, pointing to the exact same item on disk. So what if we tried to do that with the directory? So let's do ln here, and let's call it another. And it mentions hard links are not allowed for directories. Okay? So hard links are not allowed for directories. Okay. Let's see. So if we do, let's do another one. ls-li. So if we do an ln dash s for a soft link, and we did a soft link, in fact, first let's do ls-lia. So we can see we have these two special files, okay? So if we do ln dash a soft link to ... And let's call it, since this is crazy, we'll call it crazy. ls-lia. And we can see here is crazy pointing at ... So if I cd into crazy, okay, what's here? Temp. cd temp ls. Hey, there's crazy again. cd crazy ls. cd temp ls. I'm just going around in circles, ain't I? That just is weird. What if I cd here? ls. So, yeah. Where am I currently at? pwd. I'm in home EC user temp crazy temp here. Okay. But am I really at that? I mean, if I do pwd, and I think it's uppercase P. Yeah. So that'll actually tell me where I really am without the weird symbol links. Okay. So if we man pwd, we should be able to see, yeah, P is physical. Avoid all symbolic links. So it just tells me what the actual physical location is, not the symbolic link workaround to it. Okay. So what if we let's vi one. Let's vi. We'll call this text. And I'm hitting I to insert. I'm going to say, what are you doing? I hit escape, colon, WQ to save and quit. So now I can cat text, what are you doing? I'm in here. Okay? So, and that's ls-lih. And that's the only thing that's here other than getting up. So I'm going to come up a directory and cd into there, ls, and there's some text there, cat text. What are you doing? So remember, cd ... ls-lia, there is just pointing into here. So if I go back into there, cd there, ls, and I rm text, is it going to remove it from here? So ls cd dot dot, and I can do / here, ls. Yeah, they're the same. They were the exact same file because the folders were just linked. What if I, let's see, ls dash, oh wait, I want to go up a directory, cd dot dot, ls dash li. What happens if I delete 1? Does 3 go away? Because they're the exact same, right? Let's try it. rm1 ls dash li. No, 3's still there. Okay, it's the exact same. It's still there. We only deleted the reference to that inode, but the reference still exists. But guess what? This soft link that was pointing to 1 is not broken. It's not working because this is a soft link. This is a hard. They are the exact same thing. This just links to the reference. So how would I fix that? I mean, I can just touch 1 ls-li and it's fixed. Now, if it was actual information in the file, that I'd have to fix that a little better, right? What if I remove 2? Does that affect 1 or 3? rm2 ls-li. No, not really. So this is interesting. Let me tell you a little bit of why I use symbolic links and hard links. I use symbolic links mostly to redirect like log folders to the right place that I want them so I can easily watch, monitor, and forward those logs to a system that is safe. So if hackers are able to get in, they can't modify things. Also, there's a log management system that can do some general understanding of how systems are working and report. So it's a good idea to understand when and why we use these. Hard links I've used less often. In fact, I can't think of a really good instance that just makes sense. I've used them before, and I can't remember why. It's been a long time when I've used them as a system administrator. Okay, so one more thing. So we've been looking at files. Files are on file systems. So if I look at my computer, I can type in df, and I can see the different file systems that are mounted and where they are mounted to. Now, I usually use df-h, so I don't have to do math on the available or the used. I mean, the percent's fine, but the available and the used, it switches it into human readable. That's the -h. So I know that I'm using a 1.6 gig here, and I have 6.4 gigs available. Okay. Now, how do these get mounted? Well, that is, at start, there's this thing called the fstab. So let's cat etc fstab. And this is actually how it does. So slash is really the main thing here, and then the boot EUFI. These others are special. So boot and slash. The tempfs, man, this one, dev, I mean, oh, this is the boot. So these are all special ones. So usually on most file systems, I have a lot more than just slash. And let me once again explain why. One of the things that we need to do as system administrators is try and stop hackers from causing harm to our systems. And a way that we can do that is we can have our file systems so that they only fit what they're supposed to do. And if they start to, most of your file systems shouldn't grow. It should be things that are installed and running, but the log should go somewhere else. So you have your, where it grows, that is expected with the logs, but all the others shouldn't grow. So if someone puts something there and starts to gather information, to exfiltrate it from another person, or gathers information from your group, it will run out of space and cause errors, which then go to the log server and can pop up, and you can say, hey, we need to handle this. So if growth is not expected, there's no reason to have a lot of space. And so usually I have spaces for the software that's installed, the types of software that's installed, content, depending on if it grows or not. That might be a different area. It might even be a shared drive. And then there's the log areas that is expected to grow some. Sometimes some systems don't have log areas. They just send their logs to a logging server. If you don't keep logs on your local system, as long as you have a good, robust logging mechanism, that's fine. You always just go to the logging servers to get the information that's needed. Anyway, I hope you've enjoyed this. Symbolic links are very useful. I have used them heavily in my career, but they take a little bit of thinking to get on. Inodes and understanding inodes can help you accomplish quite a few tasks. And then, of course, the fstab, and that's where we manage how we're going to set up our file system. And by default, that's not set up well in AWS. So if as you get to more enterprise, bigger things, you would change that some, most likely. Anyway, I hope you've enjoyed this, and we'll see you in the next video. Have a good day.